Section 3.4, Measures of Position. So IQ scores have a normal distribution. Mean is 100, standard deviation 15. That's the way the exams are written. So find the two scores between which 95% of all IQ scores lie. So that's the idea where you take the mean minus 2 standard deviations and the mean plus 2 standard deviations. And so between 70 and 130, that's where 95% of people's IQ scores would be. Okay, what about the number 145? How many standard deviations away is that? Well, we saw right here that going 2 standard deviations away is 130. Well, to get to 145, you've got to go 3 standard deviations away. Now, change the problem just slightly. What about something in between? So it's not 130, it's not 145, so it's not a nice even multiple of 15, but it's got to be more than 130, so it's more than 2 standard deviations away. It's less than 145, so it's less than 3 standard deviations away. So it's 2 point what standard deviations away? Well, here's what we can do. Subtract from the mean. So 136 is 36 points above average. So 2 standard deviations would be 30. Or if you just divide those, 36 by 15, that gives you a 2.4. So a 136 is 2.4 standard deviations above the mean. And I know that it's above because this 2.4 is positive. So what I was just doing examples of is the Z-score. So the Z-score's job is to tell you how many standard deviations from the mean is the score. And it could be that it's something that is over the average, so then the Z-score would be positive. Likewise, if a score was below average, the Z-score would be negative. So here's the formula for the Z-score. These two are the same thing. It's just that you might have the sample information, sample mean and sample standard deviation, or you have the whole population mean and the whole population standard deviation. Either way, it's the given score minus the mean divided by the standard deviation. So as an example, we've got a mean of 75, an S of 10, and then just use the Z formula for 98. So here it is. You type that into a calculator, it will tell you it's 2.3. So if something is more than 2 standard deviations away, well, 95% of all data is within 2 standard deviations. So if it's more than 2 standard deviations away from the mean, there's only a 5% chance of that happening. It's actually 2.5% chance on the right and 2.5% chance on the left. So in general, we say scores are considered unusual if the Z-score is less than -2 or bigger than 2. This is an important idea that we're going to use quite a bit. So when you see the word unusual, it will say something like, this guy is 7 feet tall. Would you consider that unusual? That's a key word saying find the Z-score. See if the Z is over 2 or if it's under -2. Here's another way to use the Z-score. Suppose that there's these 2 exams. You're going to be graded on a curve, or in other words, you're graded against the rest of the class, not just what percent you got on the exam. So here's these 2 situations. Exam 1, you got an 85, 10 points above average. Exam 2, you got a 77, 10 points above average. But which one did you do better? So you also need to consider the standard deviation. So we're going to find the Z-score for each one of these. The first one, the Z turns out to be 1.25. So that is above average, but not considered unusually above average, but it is above average. Then for the second Z-score, you can see that's only a 0.83. So actually the first one, having a 1.25 Z-score, is better. That is more above average. And then I'm just repeating myself here. Neither of them is over 2, so neither is considered unusual. On to the next idea of the section, percentiles. So what this does, well, it says percent, so that means there are 100 pieces. What you do is you put the data in order from the smallest to the biggest, and you go through, and after every 1% of data, you put a marker. These markers are called the percentiles. Check out my hand drawing right here. Pretty cool, huh? So you start at the bottom, and then this is the first percentile. That means between these two, that's the first 1% of the data. Then the next 1%, the next 1%, etc. So then this over here would be the top 1%. Or in other words, here's a cutoff from this cutoff at P99 all the way to the left. That's 95% of the data. Excuse me, 99% of the data. While this little bit in here would be the top 1%. Now there's two things we're going to do with percentiles. One is you will look at a list of data and they'll say, hey, look at that number there, X. What is the percent? What percentile is that number at? So just count the scores that are less than it. Sort of like when I was pointing to this P99 and I said to the left of it is 99% of the data. So that's what you do, is you count the numbers less than it to the left of it. Then divide by the sample size. So in other words, this person beat 99 other people out of 100. That would be a decimal. Then multiply that by 100 and you get a percent. So here's an example without a fancy story or anything. But take this list of numbers, which happen to already be in order. Find the percentile for the 8. So you just have to count how many numbers are less than 8, 3, and you count how many scores are there total, 10. And then you say, well, that means that the number 8 beat 3 out of 10 scores, and then change it into a percentage, it's 30%, or percentile 30. Now, we need to go the other way around. What if you were given the percentile, like PK or percentile 30, this last one, what if you were given that information? So basically you then have to undo this work. Instead of multiplying by 100 and dividing by n, you do the opposite. So that we call the locator. So if this is going to be the percent, then you want to change that back into a decimal, k over 100, and then multiply by however many numbers there are. Then there's two things to consider. One, if you get a decimal of any kind, even 9.01, then round up to 10 and then find the 10th number in the list. If you happen to get a whole number, like you did the L and you got a 4, then go to the 4th number and the 5th number in the list and average those two. So back to the example. What score is at the 83rd percentile? So you count the scores. There's 10. Change 83% to a decimal, 83 over 100, then times the n. It says 8.3. So that means I need to round up to 9. And then go find the 9th number in the list. Since there's 10 numbers, then this one would be the 9th number. And so it's number 19. One more example, part B. Find the 20th percentile. So do the formula with 20 over 100 times 10, and it gives us a whole number 2. So that means I'm going to have to go to the second number and third number and average them. The second and the third number would be these two, the 3 and the 7. So then average the 3 and the 7, which is a 5. And that would be it. And then there's one last idea in this section. It's a box plot. So these are pretty easy to do if you use a graphing calculator. There's just 5 numbers used to create these box plots. They are the minimum, the first quartile, in other words, 25% of the way through the data, the median in the middle, the third quartile, which is 75% of the way through the data, and the maximum score. So for example, here's a list of numbers not in order. They don't have to be in order. But we're going to use the calculator to do this. So watch this. You get your trusty TI-84 and go to Stat and then Edit. We need to put the numbers in a list. So then type the numbers in the list. You can see I've got the last of it right there. 10, 2, 6. And then we're going to go to the place where you find the mean and standard deviation. So just go back to Stat right here, and then move over to Calculate, and you want the one variable statistics. So on my calculator it says this. I needed to put list 1 right here and then go down to Calculate. And that's where it gives you the mean and standard deviation. But when you first do it, there's an arrow right here that points down. So just use this to scroll down to the bottom of the list, and there are the numbers we need: 2, 3.5, 6, 9, 13. And then I'm going to make a nice fancy graph. Look at this. Ooh. So notice it should be drawn to scale. If you look at this little dot right here, that's not just being sloppy. That dot means, well, first I put the 2 and the 13 here, and then I averaged a 2 and a 13. So if you add them together and divide by 2, you'll get 7.5. Then I put a little dot there. Usually I just put a pencil dot and then I erase it, but I left it there so I could show you. This is where 7.5 is. That way when I need to put the 3.5, the 6, and the 9, I can judge, okay, if this is 7.5, this is 8, and this is 9. So this would be 7 and this would be 6. So you don't just put the numbers on there randomly. Try to put some scale so that this little rectangle is not necessarily right in the middle of the picture. Sometimes it's shifted over to the left, and sometimes it's stretched out really big. It just depends on what the numbers are.